1. Fluids. Number 1. Water distribution network in homes. The potable water stored in the reservoirs is supplied to the consumers through the supply network, or the one user receives drinking water from the public distribution network. The facilities that we found to be able to take the water from this network are divided in the following parts. First one, runoff. To supply drinking water to our buildings, we make a diversion of the pipeline from the distribution network. Second one, registration key. It is a valve normally located next to the connection. Third, the faucet. It is a valve normally located inside the building or in a case on the facade. And the fourth one, the pressure group. It is a specific equipment of those installations that do not have enough pressure in the network to supply the water. Finally, we have the counters, battery, and amounts. It's that tube that runs from the meter and ascends to the upper level of each house, depending if it is one plant or two plants. Once inside the house, the first element we find is a stock pipe that completely cuts off the water supply. From this key, we distribute the rest of the pipes that are provide water to the different points of the house. These water circuits are open, have an outlet at the end of a single path of arrival of the water. That's how the water arrives to home every day. This is based on the Pascal principle because pressure is constantly used by this system. Number 2. Gas distribution network in homes. Once obtained the license by the state, we began to build the network in each of the streets of your colony strategically. Narrow trenches are made and the ducts are installed at a depth of 60 centimeters. The duct is surrounded by a layer of sand and is placed on the top of a preventive plastic tape of yellow color, which serves as signaling so that the different companies that work in subsoil of the city. Finally, the trench is covered with the fluid fill and paving again. This is a process used to put the gas to our homes, because we already know that we have a boil in our houses, but we need all of this that I previously explained used to be useful at our homes, because with all this system it will be impossible for us to boil the water and other things. Dry networks. Dry networks are hydraulic structures that operate at atmospheric pressure by gravity. Only rarely and short stretches are pipes that work under the pressure of vacuum. They are usually constituted by a circular, oval, or composite sections, most of the time buried under public roads. The drainage system allows the circulation of stagnant water in the ground due to the topographical depressions and controls the accumulation of salt in the soil. As this can decrease the productivity. If a system is not installed on a site when this topographical phenomenon occurs, standing water will cause serious damage to the agriculture. The drying system leads the water back to the another part by means of pipes or networks to the canals. It is important to take into account that we must carry out a periodic cleaning in these systems. We must eliminate the mud and weeds which could cause that the efficiency system is lost and has problems. As you can see, all this is related with all the things we saw in stage 1. In every process we see that every system needs to up the pressure to work properly, started by Pascal principle and Archimedes principle. That is indirectly explaining in what I previously said.
Atmospheric phenomena. The principal atmospheric phenomenon is the global warming. This is increasing and it is behaving kind of convection. First, the radiation of the sun arrives to the planet. Then, by the pollution of everyone, this radiation doesn't can leave the planet. That provoke that the planet continue increasing this temperature.
3.
Heat source in home, factories and companies. The principal heat source in every place is the sun, and its heat is transmitted by radiation. The other source of heat is the AC, and its heat is transmitted by convection, and by the same procedure, the heat is transmitted by people and machinery. Environmental cooling in building and institutions. The most common way to cool a building is with the windows, and that make the function of let out the warm air and let in the cool air, and also with the higher ceilings, and that make that warm air goes up and the cool air go down. That make the people feel more cool and don't feel the warmth of outside. And there's also an artificial way to cool an building, and that is with the AC, and that's simple and to drop some cool air and make them the hot air make more cool.
3.
Thermal interchange devices. This is kind of the air condition, but it functions with fluids through all the house by pipes that had cool water, and it make a function of interchange of heat, and that makes the temperature of the house more comfortable for everyone.
Hi, my name is Julian Isaac and I'm going to talk about electricity, that is on stage 3. Um, the first point we are going to take to mention is the generating electricity. And generating electricity is a process of generating electric power from sources of primary energy. Primary energy can refer to the sun. The sun is a primary energy source of energy. The water is another primary source of energy. The wind also is a primary energy source. There are 7 fundamental methods that we can convert certain sources into electrical energy. One of the 7 fundamentals that we can use to convert sources of energy to electrical energy are this one. First one is the static electricity from physical contact and transportation of charge. That means that if I have a rub, for example, and if I rub it with other thing, it will produce electric charge. The other thing is electrochemistry, is the direct transformation of chemicals to electricity. An example are the batteries. Well, the other 2 fundamentals electricity is this one, the photovoltaic, the effect of transformation of light into electrical energy. A good example of this is the solar panels. Here we have the sun and is transmitting the light to the solar panels that converts them directly into electrical energy. Some companies are using this method to reduce the consumption of electrical energy. The thermoelectric energy is the direct conversion of heat or temperature into electricity. The other 2 fundamental sources that we can change to electrical energy is this one, the piezoelectric effect. It generates electricity when we take out a certain amount of energy from some crystals. The other is the electromagnetic induction. It, it needs an alternator that transforms kinetic energy into electricity. We have an example here. This is a transformator. It helps the house for electricity, and the lights turn on.
3.
The last fundamental way that we can change to electrical energy is this one: the nuclear transformation. Is the creation of the acceleration of the particles. The scientists use radioactive stuff to make electricity. A good example is this one: the nuclear reactor. The way that the nuclear reactor works is that the heat of the radioactive um, trash accelerates an engine. This engine works with heat. When this engine works, a mechanical process it's going, so the electrical energy comes from the mechanical work of the nuclear reactor. Well, other sources to obtain electrical energy are this one. The first one is power plants. They burn fossil fuels to create steam. They also burn coal that it is obtained from mines. And the renewable energy, the renewable sources. Almost everybody knows about them. The first one is the sun, is our star, is unlimited source of energy. Water is also known as hydro source of energy, and there is the wind that also is unlimited. It's also called aeolic energy. The biomass is the same as the fossil fuels because it is the rest of fossils. And the geothermal, that it is the heat, the steam that comes from inside the earth. Now we are with magnetic fields. All moving charges such as electrons, protons, neutrons, all moving charges can produce a magnetic field. Moving charges such as electrons can produce a magnetic field, but depends on how fast the particle goes. It depends on the charge, obviously, the velocity of the particle, and the acceleration of the same one. The last point that we are going to talk about is the domestic electrical circuit. I think that a really good example of a domestic electrical circuit is a little lamp, and I tried to show to draw it as a representation of what happens when we turn on this lamp. First, the anode. No, sorry. First, the cathode take out some particles. Then the electrons flow through the light bulb that makes it turn on like this. Then from the light, other electrons flow, and the anode is in charge to take that electrons to the battery. This is an actual representation of a battery. This is a simple battery, and what covers the battery, it's called membrane. This is a very simple electrical domestic circuit. I think that indeed is a very simple electrical circuit.